A very good morning to all the students. I hope every one of you is fine and in your best health. So before we start our today's lecture, let's go through to some guidelines which we have been following since this pandemic of COVID-19 has occurred. So we have been wearing masks and following physical distancing, but somehow we have forgotten all these things now, and everyone is leading their life like a normal we were doing before. But this pandemic is not yet over, so we need to follow these guidelines regularly as we were doing before. So for that we have to wear our mask properly. We should stay at least 6 feet away from each other. We should wash our hands frequently. Whenever we touch any surface or whenever we have any physical contact, first of all, we should avoid the physical contact. But if we do, we have to wash our hands. We should always sanitize our hands. We should wash our hands with the help of soap and water, at least for 20 seconds. And we should remember not to touch our face very often, and we should not share our foods and drinks with the others. Now, keeping all these things in mind, these things will make us safe and our family members safe, and we will not be infected from this COVID-19, because this is a dreadful disease because it communicates very fast and it spreads. So it's better to have precautions than cure. So all these preventions will make us safe from this disease. Okay, so you will all keep all these things in your mind always, and we will always wear our mask. We will follow physical distancing and maintain the hand hygiene. Okay, so a very good morning to all the students. Today in this lecture video, I will be solving all the questions which I have given you for the exercise homework, which are from your NCERT book. Now, I have seen that many of you have not submitted your homework. Reason being maybe that you are unable to solve those questions because they include many questions from the whole concept as well. So here I am solving the questions for you so that you can understand the question properly, and then you can submit your homework again. Okay, so let's start with the first question, which is 0.24 grams of sample of compound oxygen and boron was found by analysis to contain 0.096 grams of boron and 0.144 grams of oxygen. Calculate the percentage composition of the compound by weight. So in this question, we have been given grams of sample of, they have oxygen and boron mixed. Okay, so the total sample, the weight of the sample is 0.24 grams, okay, which has oxygen and boron. In it, they have this grams of boron quantity is given and 0.144 grams of oxygen quantity is given, but we have to calculate the percentage of boron and oxygen in this sample. So there is a formula to find out the percentage. We can write mass of anything given upon mass of the sample into 100, and from there we can find out the percentage. Okay, so let's start chapter number 3, and these are the solutions of exercise. Okay, so the first question. So in this, first we'll write what has been given to us. Okay, so the things which are given to us are, number 1, we are being given mass of sample. It has been given in the question itself. It is 0.24 grams is the mass of the sample. Then we have been given mass of oxygen. Okay, so that is 0.144 grams, and then we have been given mass of boron. So all these things are given in the question itself. So out of these we have to calculate the percentage. So now next we'll write the formula. So percentage of oxygen, formula is mass of oxygen upon mass of sample into 100. Okay, so percentage of oxygen will be, now mass of oxygen is being given, it is 0.144 grams upon mass of sample is 0.24 into 100, which will become 60% when we will solve it. So this is solved. So now next is percentage of boron. Okay, so now this is again mass of boron upon mass of sample into 100, which is mass of boron is given 0.096 upon 0.24 into 100, which is 40%. So we have got the answer. The percentage of oxygen is 60% and the percentage of boron is 40%, and this is the answer. Okay, so let's move to the next question. Question number 2. In this, when 3.0 grams of carbon is burnt in 8.00 grams of oxygen, 11 grams of CO2 is produced. So when we burn 3 grams of carbon, it is burnt with 8 grams of oxygen, so it produces 11 grams of CO2. So that has been given from the book. Okay, so the next part of the question is, so what mass of CO2 will be formed when 3.00 grams of carbon is burnt in 50 grams of oxygen? First of all, we have read that according to the law of constant proportion, any chemical compound needs a specific ratio. So we can't change the ratio. So when it needs always according which law of chemical combination is governed. So according to the answer is the law of constant proportion. According to law of constant proportion. Okay, so according to the law of constant proportion is governed in this question. So according to this law, every single compound has a fixed proportion of the elements which combine together to form that compound. So in this, carbon and oxygen combines in a fixed proportion of 3:8 ratio by mass. Okay, so they produce 11 grams of CO2. Okay, now the same CO2 will be produced, but because if we will have only 3 grams of this CO2 carbon, and we have more than the oxygen, but only 3 grams of carbon will be burnt in the 8 grams of oxygen. Rest of the oxygen will be left spare. It won't be used because they can't add up more oxygen to get the compound called as CO2. So the same mass of CO2, that is 11 grams of CO2, will be obtained even if we burn 3 grams of carbon in 50 grams of oxygen. So that means 50 grams of oxygen was there, but only 8 will be this only 8% will be used. So that means 42 grams of oxygen will remain unused or unreacted, because only 8 grams of oxygen is required to burn with 3 grams of CO2, carbon. So only 8 grams will be used and rest of the oxygen will be left in the atmosphere itself. Okay, so this is done. Now the next question is what are the polyatomic ions? I think you would have done this question because this is very simple. You have done it many times, so I'm not solving this question. What are polyatomic ions? You already know that when 2 or more different atoms unite to form a charged particle, which is called as polyatomic ions. And the next questions are from this how to write the chemical formula. I think you all know how to write the chemical formula, so I'm not going through this, but simple thing, whenever there is a question to write the chemical formula, for example, we'll take the first question, which is magnesium chloride. So it will be Mg and Cl. So it has valency 2, it has valency 1, so it will be MgCl2. Okay, this is how you have to solve all the questions of these types. So next question is calcium oxide, CaLCium, calcium oxide. Okay, so again this is Ca2 here and O2 here, so it will be CaO. Okay, so C is next is copper nitrate, it will be Cu, and nitrate is NO3, so it is Cu has a valency 2 and nitrate has a valency of it has just valency 1, so it will be CuNO3. No, copper has the valency, yes, copper has valency 2 and NO3 has valency 1, so it will be Cu2NO3 Cu. So this 1 will come here, so CuNO3 whole twice. Okay, so CuNO3 whole twice. So next is aluminium chloride. It's Al, okay, for aluminium, and for chloride it will be Cl. Okay, so aluminium has valency 3 and this chlorine has valency 1, so it will be AlCl3. so the E will be calcium carbonate. Okay, so it will be CaCO3. Calcium has valency 2, carbonate has valency 2, it will be here like this, it will be CaCO3. Okay, I hope it's clear. So please don't get confused, it's CuNO3 whole twice. Okay, CuNO3 whole twice. So now this is it. After this comes to the next question. Give names of the element present in the following compound. So quicklime has, okay, we'll do it quickly. So question number 5. So quicklime has calcium oxide, which is CaO. Okay, CaO, and the element has calcium and oxygen. Okay, so B is hydrogen bromide. So hydrogen bromide is called as HBr, which means it has hydrogen, which is H, and bromine. Okay, bromine means Br. Okay, so next is C, baking powder. Baking powder is called as sodium hydrogen carbonate. It's sodium hydrogen carbonate. Okay, which is the formula of NaHCO3. It has sodium, it has hydrogen, it has carbon, it has oxygen in it. Okay, so sodium is Na, hydrogen is H, carbon is C, oxygen is O. So D. Okay, so the D is potassium sulfate, and potassium sulfate is K2SO4, okay, which has potassium in it, then it has sulfur in it, and then it has oxygen in it. Okay, potassium, PATOSSIUM, sulfur, and oxygen, you know. Okay, so this is also done. So calculate the molar mass of the following substances. Molar mass is very simple. I think you can do it by yourself. You just have to calculate this. No need to solve this, but if you want, we'll be doing this. So question number 6. So molar mass of C2H2. It is very simple. Like it's C, carbon is having atomic mass 12. Okay, so 12 into 2 plus H into 2, which makes it so 12 into 2, 24 and 26 grams. Okay, so for it's A. Now B, sulfur, S8. So sulfur has atomic mass 32 into 8, which is 256 grams. Now C is P4, phosphorus molecule. So phosphorus has atomic mass 31 into 4, which is 124 grams. Now D is HCl. Okay, so HCl, hydrogen 1 plus 35.5 chlorine. Okay, so it makes 36.5 grams. Now next is nitric acid. So E is HNO3, nitric acid. So nitric acid have hydrogen plus nitrogen plus oxygen into 3, 1 plus 14 plus oxygen into 3, which is 15 plus 16 into 3, it will form 63 grams. Okay, so this is also done. Now next question is, what is the mass of, now there comes the mole questions based on mole concept, which I wanted to do for you. So now this is 1 mole of nitrogen atom. You have to find out how many moles are there in 1 mole of nitrogen atom. So 1 mole of nitrogen atom has equals to like 1 into, so what is the weight of nitrogen atom? It has to be gram atomic mass of nitrogen, which is 14. So 1 mole weight has mass of 1 mole 14 grams will be the mass of 1 mole, because the mole of nitrogen atom will be the atomic mass of nitrogen. Okay, so that is 14, it will be 14 grams. Okay, so the next is 4 moles of aluminium atoms. Okay, so now mass of 4 moles of aluminium atom, what it will be, like it will be obviously the mass of aluminium atom. So the mass of aluminium atom is 27, so it will be 4 into 27 grams, which is 108 grams, because 1 mole equals to 1 gram atomic mass of that atom. Okay, so therefore mass of 4 moles of aluminium atom will be like 4 into 27 grams, because aluminium atom, you have to write atomic mass in grams, because it's called as gram atomic mass. Okay, so now C is 10 moles of sodium sulfide. Sodium sulfide is Ne2SO3. Okay, so now 10 moles of sodium sulfide, which is Na2SO3. Now this 10, it will be the same value, like it will be the gram at molecular mass. Now it will be gram molecular mass because it is a molecule, so we have to find out the molecular mass of this. So 10 into it's 2Na, 2 into Na plus sulfur plus oxygen into 3. So it will be 10 into 2 into 23 plus 32 plus 16 into 3, which will be 46 plus 32 plus 48 into 10. So it will be 10 into, total will be 126. So it will be 1260 grams, because it is a gram, it will be gram molecular mass. Okay, this. So now convert, next question is convert into mole. We have to convert this into mole. Okay, so question number 8. We have to convert 12 grams of oxygen gas into moles. So how we will be doing it? It's a very simple. Before this, we will write it 1 mole of oxygen equals to, okay, so oxygen gas is given. When it's gas, so it will be O2. Now oxygen atom is O, but oxygen gas is a diatomic gas, it will be O2. So O2 has atomic mass 32 and oxygen has atomic mass only 16. You have to keep in mind, because 16 into 2, 32. Okay, so here they are saying about oxygen gas. Okay, so gas means it equals to 32 grams. Because what is mole? Mole is a relationship between the number of atoms and between the mass of that atom. So there is a relation between mass and number. So 1 mole of oxygen means it has to be 16 grams. And when we talk about oxygen gas, it will be O2, that means 32 grams. Okay, so therefore 32 grams of oxygen equals to 1 mole. Okay, so then therefore 12 grams of oxygen will be 12 upon 32. Clear? Or it can be 1 upon 32 into 12. So which makes it, when we'll solve this, we'll get 0.3575 mole. Okay, so now next is 20 grams of water. We have to convert 20 grams of water into moles. Okay, so here water consists of H2O molecules. So the water is H2O actually. So H2O molecule has the atomic molecular mass, we'll say. So 1 into 2 plus 16, which is 18 grams. So 1 mole of H2O equals to 18 grams. Therefore 18 grams of water equals to 1 mole. So 20 grams of H2O will be 20 upon 18, which will be 1.1 mole. Okay, this is the answer. So next is 10 moles of sodium sulfite. Okay, so this 10 moles of sodium sulfite, we will be solving this. No, we have done this already. Okay, so we are doing in this question. So 22 grams of carbon dioxide. Okay, so see, so for this 22 grams of carbon dioxide, again we can do, so 1 mole of CO2. We know that CO2 has 44 grams, 44 U is the molecular mass of CO2. So it will be 1. Therefore, 44 grams of CO2 will have 1 mole. So 22 grams of CO2 will be 44 upon 22, which is 0.5 mole. Okay. So these are the simple questions which you can solve by your own. So I think this is enough for today. So next, the rest of these questions I will be doing in the next lecture video. And we will be doing some more questions like this in the next lecture, and then we'll be starting our next chapter. Okay, so please try to solve all these questions once again, and if you have any problem, just let me know. Okay, but please do your homework, everyone. Thank you.